All right, welcome back again, pre-calculus people. We are going to be talking today about even and odd functions and kind of what that means, not only graphically, but really algebraically, and how to kind of run a test to see if something is even or odd, okay? I think I like going through the definition graphically first, so you can have an understanding visually of what's happening, then we'll do the algebra in a few minutes. So starting out with even functions. So this is the actual mathematical definition of an even function, f of negative x equal to f of x. So let's think about what that means graphically, right? So if you see these three graphs up here, really what's going on is it's symmetric about the y-axis, right? So if you think about that, if you just pick any x value over here, so like on the middle graph, so like if you pick this point at -2, it's at 0, and at +2, it's also 0. You can do that with any point, right? So if you go to like 5 and pick that point, and then -5 and pick that point, it's still that same x value. So that's kind of what that's saying, and all these graphs are the same. So you got the quadratic graph that's been just kind of moved up a couple units. This is actually the cosine graph. You don't need to worry about that one just yet because that's going to be more second semester. But that's what that means, right? So the parent functions that are even, you should know this as far as for your test, quadratic and absolute value. Are all quadratic and absolute value functions even? No. If they're shifting left and right or something else going on, then they're not even anymore. But the parent functions definitely are. Okay, so if you see a graph and it's symmetric, if that y-axis kind of chops it in half, a mirror image on both sides, and it's symmetric about the y, then that means it's even. Okay. Now, how about odd function? You might be saying, well, wouldn't an odd function just be symmetric about the x-axis? That's not quite what it is. So for the odd functions, what happens is it's when it's equal to the opposite. So again, here's the actual definition, and we'll get into the algebra side of it in a minute. But now what it means is it's actually symmetric about the origin. Now, what does it mean to be symmetric about a single point? Well, it means you can flip it upside down, it looks exactly the same. So if you think about the rational function, if you flip that upside down, notice it still looks like it's in the first and third quadrant, just like it is normally, right? Same thing, this is a cube root function. So again, if you flip it upside down, it's kind of rotated around, it looks the same way. So that's kind of what it means to be symmetric about the origin, okay? And again, paired functions that are odd, there's actually quite a few of them. The cubic function, which again, the cubic function is the one here at the bottom. The cube root function is in the middle, it's reflected, but still the cube root function. And the top function is the rational function. Also the linear and the sine function, those are also odd functions. Again, paired functions odd, transformations may not be odd all the time. Obviously, a lot of functions are not even or odd. So there's a couple paired functions that are neither, and that's a square root, exponential, and a log. You might remember that mainly just because they have kind of a stranger domain. So like the square root and the log function kind of go from 0 to infinity, and then the exponential has that, it never goes across the y-axis and it doesn't go through the origin, so it's not symmetric about that either. So those are the three that are neither. But again, a lot of these other paired functions, if they're translated at all, are not going to be even or odd either. Okay, so that's your graphical representation. Let's talk about the algebra behind it. So really what you do to determine if you don't see a graph, you can determine if something is even or odd just by running a quick little test, right? So the test that we run, the first thing we do, we're going to plug in negative x, literally plug it in to all the x values in the function, and then see what happens. Once you plug it in, we're going to clean it up, just kind of, do any kind of exponents you got to deal with or what have you. And then once you clean it up, we're just going to compare it to the original, because that's kind of what the equations say is once you plug in that negative x, is it exactly the same or is it the opposite? And if it's exactly the same, once you get it cleaned up, then that means it's even. If it's exactly the opposite, in other words, all of these signs change all the way through the equation, then that means it's odd. If none of those things happen, then it's neither. right? So you only have a choice of those three things. Okay, so plug in a negative x, clean it up, compare it, and then same, even, opposite, odd, neither, neither. Okay, so let's run through a couple of examples real fast, and we're going to run through that test and kind of see what happens on these guys. So plug in negative x. So for f of x equals 3x squared minus 5, we plug in negative x. Remember, we're plugging in exactly what it looks like, right? So 3 on the outside, plug in the negative x, square it, and then minus 5. And then the clean up part, so we know that negative squared, so like negative times a negative, it's going to be a positive. So this is going to end up being just 3x squared minus 5. And that is still f of negative x, right? So we go back and we compare it to the original, and it is the same thing. So it is exactly the same. So that means it is even. Okay? Exactly the same as even. Let's take a look at another example. 2x to the third minus x. Again, we always do that same test. We're always going to plug in the same thing. So f of negative x equals 2, again, negative x to the third power minus negative x. Always a good idea to use parentheses. You've been hearing that for years now. And again, clean it up. So in this case here, so we have negative to the third power. So negative times a negative times a negative is still a negative, right? So we can write that a couple different ways. So we can do this like this, really. We can do it that way, because it's still going to be a negative. And then that's going to be a plus x, negative times a negative. And then that negative can just move outside the parentheses since I'm just multiplying by that stuff. So it's really this. Okay, so now again, we look at this, we compare, and we see that it initially was positive 2x to the third minus x. Now it's negative 2x to the third plus x. That is exactly the opposite. Again, all the signs changed. And if it's exactly the opposite, that means it is odd. Okay? So again, plug in the negative x, clean it up, see what happens, compare. Got 2 more examples for you, so let's do another one here. So again, plugging it in first. Always using parentheses. This is kind of the same thing as the first example. Notice I have a negative x and it's squared, so negative and negative again is a positive. So we have that. And again, compare it. We have, this is my new one, that's my original. We compare those, they're exactly the same. So again, that is another even function. One more example and we'll wrap it up. So here's another one. So again, we don't do anything different. 3 over negative x plus 2. So that's our function. There's not a whole lot we can clean this up. The only thing we can do, if I've got a positive divided by negative, it just makes the fraction negative. So I can write this as negative 3 over x plus 2. And again, we compare, because I can't do anything else. So what happened? So my original, I got a positive, the fraction was positive, 3 over x plus 2. Now my fraction is negative, but I still got a plus 2. Remember, if it's going to be odd, it clearly isn't even, because it's clearly not the same. And the only way it's odd is if everything changes sides, like literally everything. In this case, the 2 didn't change sides, so it's not the same. It's not the opposite. So it is neither, or neither, whatever you say. So that is the test. That is the algebraic test of even, odd, or neither. And a little bit about the graphical representation of even, odd functions. And we're even, symmetric about the y-axis, and odd is symmetric about the origin. Okay, that is all for that. There's an assignment up for you to do over the weekend, pretty short assignment, just on verifying that. As always, if you need some help, let me know. And until next time, stay safe.